Precalculus or calculus with examples. Use precalculus when you need to find slope of a line, slope of secant line to a curve, rate of change from time A to time B, area of rectangle, length of a line segment, or work done by a constant force. Use calculus when you need to find slope of a curve, tangent line to a curve, instantaneous rate of change at t equals c. Area under a curve, length of an arc, volumes and surface area of solids of revolutions, work done by a variable force. So let's do an example. Example 1, finding the rate of change. So here is a bicyclist. He's riding on a path modeled by the function f of x equal to 0.03x, where x and f of x are measured in miles. Find the rate of change of elevation at x equal to 4. Example 1, solution. Since the path of the bicycle is given by the linear function f of x equal to 0.03x, we can use precalculus because it's a linear function. And by definition, rate of change of elevation is slope, and the slope is 0.03. So the rate of change of elevation is 0.03, and that is constant no matter what the x value is. So therefore, at x equal to 4, the rate of change stays 0.03. Go to find the example 2, finding the equation of line. Find the slope intercept form of the equation of line passing through these 2 points, 7/8, 3/4, 5/4, -1/4. Okay, let's step 1, let's find the slope of the line passing through these 2 points. So let's see, x1 is 7/8, y1 is 3/4, x2 is 5/4, and y2 is -1/4. So let's write the slope formula, m equal to y2 minus y1 over x2 minus x1. So let's substitute x1 equals 7/8, y1 is 3/4, x2 is 5/4, and y2 is -1/4. So it becomes y2 becomes -1/4, y1 is what, 3/4, x2 is 3/4, 5/4, and x1 is 7/8. Now as you can notice, the fractions on the numerator, they have same denominator, so these are like fractions. So we can add the fractions on the numerator, but on the denominator they are not like fraction, so it looks like LCD is 8, so we can multiply 5 with 2 and 4 with 2, so both fractions will have then same denominators. Okay, so this becomes -1 minus 3 over 4. So, and this becomes 10/8 and 7/8. Now we simplify this one, it will be -4 over 4, and 10 minus 7 would be 3 over 8. Now -1 over 4 is -1 over 3/8. So now this is a complex fraction. So what do? Multiply the numerator by the reciprocal of 3/8. So we -1 times 8 over 3. So which is equal to -8/3. So the slope is -8 over 3. Okay, we already found the slope, and it's a -8/3. But you can use the first point, 7/8 and 3/4. And we can write the point slope form of the equation line, which is y minus y1 equals m times x minus x1. So let's substitute m is -8/3 here, and x1 7/8 is here, and y1 3/4 in this place, and just copy y and x's. Now on the right side we distribute -8/3 times the x, and then -8/3 times 7/8. So it's right, negative times -8 times 7/8. We can simplify, negative becomes positive, 8 cancel with 8, so you're left with 7/3. Now we move the -3/4 to the right side. So as you can see, 7/3 and 3/4, they have different denominators. So we find the LCD, which is 3 times 4, 12. So since 3 times 4 is 12, so we multiply first fraction 4 over 4. And the second fraction is 4 times 3 is 12, so the second fraction we multiply 3 over 3. So now the 3 comes 7 times 4, 28 over 12, it will be 9 over 12. Same denominator, we can add the numerators, 28 times plus 9, 37 over 12, and copy everything. So I think that's the equation of line we are looking for, and that's a slope intercept form.